we have done Sp hybridization. Today we are going for Sp2 hybridization. Sp2 hybridization. See, this is S and we have three p orbitals. Okay, three p orbitals. So out of this, we are going to mix. With this, we are going to mix S and two p orbitals out of three. So this is called Sp hybridization. Okay. So in this case, say it is Z, say this is X, and this is Y axis. Okay. So out of the three, we are going to mix two. All right. So in that case, what is going to happen? Say it is this. Huh? And out of the three, see, they are perpendicular to each other. Is it not perpendicular to each other? Say, I have not taken this, I have taken this, so they lie in the same plane. So this is one orbital, and this is the another orbital. Clear? Say I have taken it is Z-axis. Z you always have to take because overlap of them or gives us principal. So sigma 1. I have added this. So what we are going to get if I hybridize it, because we know as many orbitals you will mix, you will get same number of hybridized orbitals. So it's 1 plus 2. So we are going to get set of 3 hybridized orbitals. All right. So this. No, I will not do it. See, we cannot separate the orbitals. So out of the 3, I have taken this and this. This is still there. So what I will do? What will happen? This. These are the set of 3 hybridized orbitals. Okay. So what is the shape now here? See, this is planar. This is called trigonal plane. All right, but one of these orbitals I did not mix, and all these 3 orbitals are 90 degrees to each other. So in this case, you will find this will be the unhybridized P orbital. This will be the unhybridized orbital, and these 3 are the hybridized orbital. How do you know? Because looking at the small lobe. So these are 3 unhybridized orbital, and this is the unhybridized P orbital. What is the angle here? Angle is 120 degrees. Draw it. So we go for BF. Okay. Always central atom. This is the atom which get hybridized, not this other one. So what is boron? Boron is 5, 1s2, 2s2, 2p1. Okay. Let me write here now. So I instead of 2p1, I'll write here 2px, 2py, and 2p. Okay. So now say it is 1. So now in this case, see here. So I go like this. Inner orbital do not take part in bonding. 2s, 2px, and 2py, and 2pz. Okay. See, by this is by what should I say? By convention. Whenever you mix orbitals, you have to mix that because we hybridize orbital are formed by the overlap of z orbitals. We have considered z to be the principal axis. All right. So it is by convention because we have not seen the orbitals, but we have assumed that any type of sigma bonding will z orbital is involved, and all hybridized orbital they form sigma bond. See now. So it is we have to take 2 orbitals. So I'll take this and I'll take this. All right. So in that case, this is the ground state, and this is the excited state of hybridization. In this case, what is going to happen now? See, 1s2. Now we have taken this and this, so plus this. So we have mixed 3 orbitals. So we are going to get here 3 hybridized orbitals. I cannot call it S, I cannot call it P. So I have to call this one as Sp2. How many electrons we have? 1, 2, 3. So 3 electrons. All hybridized orbitals are degenerate, means they have same energy. So we have to follow Hund's rule of maximum multiplication. We put 1, 1. Please see dear, 2py I did not take. So as I did not mix 2py orbitals, its energy did not change, its shape did not change. So what will be the orbital diagram? Orbital diagram will be like this. Is the hybridized. We'll have 1 electron here, 1 electron here, and 1 electron here. But this I cannot leave it because it is in the core of the nucleus. It is inside the atom. So in that case, in your book they did not mention, but we are being told to draw it like this. See, look here. From here only you can make it out which one is hybridized and which one is not hybridized. In unhybridized orbital, size of both the lobes are same. So this is the unhybridized p orbital. All right, this is the unhybridized p orbital, and these 3 are hybridized. So this is the Sp2 hybridization of boron. Okay, this is Sp2 hybridization of boron. Now I have to draw BF. So I'll draw separately. So it is boron, this. See, you have 1 electron. And fluorine always binds through p orbital because bonding takes place only with the unpaired electron. All right. Now If you wish, you can give this orbital or you may not give this. So this is Bl. What is the shape? Shape is trigonal planar. What is the bond angle? See here. So I draw the axis now. Yeah, like this. I draw the axis now like this. This is the axis. So this is 120 degrees. So I write here now 100. Relations. Other examples. This is BCl3, BBr3, okay, BH3, then AlCl3, etc. are examples of the hybridization. So if they have given BCl3, no problem. Everything you draw like this. Instead of fluorine, put chlorine. If it is Br, instead of fluorine, put bromine. If it is aluminum, instead of aluminium, you will put, instead of boron, you will put aluminum. In case of aluminum, what you will do? Aluminum, you will write here now. It is 1s2, 2s2, 2p6, 3s2, 3p1. So now I will draw Sp2 hybridization of some other elements. So we'll go for now Sp2 hybridization of carbon. Okay. Sp2 hybridization of carbon. Okay, no problem. The carbon is 1s2, 2s2, 2p, x1, 2p y1, and 2p z. Okay. So now I'll write this one. Ground state 1s2, 2s2, energy should be higher, 2px1, 2py1, and 2pz. So what I'll do now, I'll take this. I'll take this. I told you I have to take z, 2pz. All right. So in this case, what will be the hybridized state? It will be this. So I'm going to mix this, this, and this. So it is, see here, it is 1s sp2. So out of three orbitals, and how many electrons are there? 2 plus 1, 3. See, I did not take this one. So this, and this is the one which I did not take. So its energy and shape did not take. So what will be the Sp2 hybridization? All Sp2 hybridization looks same. See here. This, and these orbitals have electron now. So this orbital electron will be okay. So this is unhybridized. P orbital. And this light I'll write here. Yeah. Unhybridized orbital perpendicular to the plane. That plane is perpendicular to this 90 degree. Angle 120 degree.
In the ground state, you gave 2px1, 2py1, and 2pz.
Yes, see here. This is the electron I have drawn here. This is the electron. This is the nothing is there. I did not write anything.
And sir, in excited state, which one did you not take?
Excited states. This is the one I have taken. This and this.
Okay, so you didn't take
This one I did not
2py.
take. So I can write here 2py.
Okay, sir. Thank you, sir.
Py did not take.
Thank you, sir.
So now we'll go for application of this one. Please remember that in between any two atoms, if double bond is there, in that case, most of the cases those elements are sp2 hybridized. Okay, so if it is C2H4, I've done intentionally because in the exam they will give you like this. C2H4 is what? C2H4 is this. This is ethene. So here both the carbon are sp2 hybridized. So you know hybridization of sp2 carbon. I told you the hybridized orbital for sigma bond. Okay, this is the one. Here you have one electron, here you have one electron, here you have one electron. And here I write opposite because you know only opposite spin pairs are. Okay, and this is the unhybridized p orbital, which has one unpaired electron, and this is perpendicular to this plane. Okay, so if this is the plane, this is the see. If this 1, 1, 2, 3, these are the hybridized, unhybridized p orbital is like this. So from top it will overlap, and from bottom also will overlap. It will be like this. Okay, so this is this. This is this. Okay. Now here I will put hydrogen. Here I will put hydrogen. Here it will be hydrogen, and here it will be hydrogen. Okay, then what is the angle here? See here. This is the axis. This is a sigma bond. This is the pi bond. Only one pi. Top, see it is like overlap has taken place like this. This is the unhybridized p orbital. This is the unhybridized p orbital. Overlap has taken place like this. So this is one pi bond. On top and bottom it is taken up. Okay. So this is the axis. This is a plane. What is the angle you have now here? Angle is 100. So what is the geometry? Geometry is planar. Geometry is what? It is planar. And bond angle? তোমার কথা শুনলেই আমার গন্ডগোল। তুমি যে পাইপ আনলে খালি বিরক্ত আজকে আনছিলাম না।
আমি কি বিরক্ত? আমি জল না, আমি তো কালকে তুমি বাইরে বের করেছে।
বলে আগে নিয়ে চলে আস কোথাও যে জল পড়ছে এটা তো I'll do Sp2 hybridization for nitrogen. Okay? And oxygen also. So now for nitrogen. For nitrogen. Nitrogen is 7. 1s2, 2s2, 2px1, 2py1, and 2pz1. Z2 you have always have to take. So here I will take now here ground state. See, in where I have written excited state now, you can write hybridization, hybridized state. All right. So because I do not know what your miss or sir will consider, so instead of excited state, please do the correction, write the hybridized. Because my concept and their concept may not match. But whatever I'm saying, that hybridization can take place at excited state because it requires energy. So it is 2s 2px and 2py 1 2 z to I have to take. So now I write here now hybridized. So here I will write now 1s2 1s. So this and this. Okay, Sp2 2 plus 1 electron 3. So 1 1 and 1. And this I did not take. So it is 2py. Okay. Now what is the structure? Orbital. What is the orbital structure? Orbital structure is. Hey, I made a mistake. No, Kun. See here. How many electrons are here? 2, 3, 4. So there are 3 orbitals are there, na? So it is 1, 2, 3. I'll put here 4. So you have 2 unpaired electron and 1 paired electron. The paired electron will not take part in bonding. Generally, we call it lone pair. See here. Shape of all sp2 hybridization is same. All right. So it is, I write like this. Okay. So now say it is this. This is this, and this is this. And this unhybridized orbital will be perpendicular to the plane. If this is the plane, it will be like this. Okay. So I'll draw it like this. This. Okay. So here I'll write unhybridized. P orbital perpendicular to the Sp2 plane. Okay, so this is the average. Now we are going to draw orbital diagram of this molecule. Okay, this class of compounds are called imine, IMINE. So first you draw. Okay, now I'll draw it like this. This one, huh? So I'll draw nitrogen. See this guy, I told you, this any atom where you double bond, both the atoms are sp2 hybridized. All right. So now so we know how to draw the hybridized orbital of carbon, sp2 hybridized. Okay, see here. See, say this one is that pair of electron. I can put pair of electron in any of the orbitals. This is this. Okay. Now this is this. This is this. This for the 3 electron of carbon. And nitrogen pair of electron, unpaired electron, unpaired electron. So it is going to form the sigma bond. Okay. Very good. Now this is the unhybridized orbital having unpaired electron. This is the unhybridized orbital having unpaired electron. So they overlap to form pi. Okay. Now see, this is the H. This is the H, and this is the H. This. Okay. So now, if this is the axis, so what is the angle here? Here also the angle is 120 degree, and here also the angle is 120 degree. Okay.
Yes, sir.
Now we go for oxygen. Yeah, everything you can draw here. Oxygen. See, oxygen is 8. So it will be 1s2, 2s2, 2px, 2py, 2pz. 7, na? Then 8 electron will come here. All right. So it will be like this. All right. So here also we'll mix this and this. All right, this and this. So here I'll write hybrid. So it will be 1s2. 3 of them will be there. This, and this. Okay. Now how many electrons are there? Count. 2 plus 2, 4 plus 1, 5. So I have to follow Hund's rule. First I'll put here 1, 2, 3, 4, 5. And PY did not disturb. So PY will have 1. All right. So now you know how to do it. Okay. See here. I'll draw it like this. This is oxygen. This is 1. This is second. And this is the third. This is the hybridized orbital. Okay. So I'll put this on here. This pair of electron here. This pair of electron here. All right. This 120. And this one did not mix, so it is not going to change its shape. It will dumbbell shape. Right. So this is the sp2 hybridization of orbital diagram of, you can write down orbital diagram of sp2 hybridized oxygen. Orbital diagram of sp2 hybridized oxygen. This. All right. So you draw for carbon, draw for oxygen. Okay, I'll draw. See, this one. I told you, double bond means both the atoms are sp2 hybridized. So I'll draw it like this. C. Okay. So draw this, draw this, draw. In your school exam, don't draw the smaller loop, huh? Because in your book it is not being there. But I'm telling you it is wrong. See, I'm not authority, but I have read the theory. This oxygen. See here, exactly I draw like this, and this is the one I'll put ulta. And this is the unhybridized pure product. Always make it opposite spin. Okay? See, this is 1 sigma, and this is the pi. See, this is the hydrogen. This is the hydrogen. Okay? This one is called formaldehyde. Formaldehyde. Okay, that's about. মানুষ যদি পূজার ঘুরতে যায় লিগে ভগবানের বৃষ্টি দিয়া বাড়ি থাকতে several examples of the sp2 hybridization. Now we'll go for sp3. sp3 means we are going to take all the 3 p orbitals along with s. sp3. Okay. So sp3, what will happen? This is the s orbital, and hello, Pumpa. Good morning. Good morning. ও আচ্ছা ঠিক আছে দাঁড়া আমি দিদি সানো গেছে না দিদি this is this and this is this. So it is p. So here what you have now here, px, py and pz. So we are going to mix all of them. After mixing all of them, please remember there this is 3-dimensional. So your hybridized atom also will be, the orbital also will be 3-dimensional. Okay, so it will be this, and this will be, see here. So see, how does it look like? Okay, so this is, I'll draw it a little better way. I'm very poor in drawing. So it is like this, then this is the other one, and this. So it is, see here. This is tetrahedral. Okay, and if this is the axis, these are the axis. Okay, bond angle is 109.50. Sp2 hybridization of carbon. Okay. Sp3 hybridization of carbon. Two PF1, 2PY1, and 2P. Okay, here I will take all three because it is called P3. Now, right now here, C6, 1S.
ঠিক আছে, তুমি এটা করে একবার বাড়লে পরে না, তারপরে তোমার মূলাচুলা খুলে এমনি
See here it is 1. So here we will take this, and this. Okay. So how it will look like? Okay. After hybridization, this is 6. This is 1s. Now I have mixed 4 orbitals, and so I'll get 4 hybridizers. So it is Sp3. See how many electrons are there? 2 plus 2, 4. So it will follow Cohn's rule. Why? Because the energy of them, all 4 of them are same. 1, 2, 3.
হ্যাঁ, তারপরে এখন তো তোমার বৃষ্টির জল ভরে ভরে আমি একটু আগে তোমার দাদাকে বলেছি যে ওষুধ না বাজিয়ে থাকবে না আমার।
I have done little longer to show you the hybridized structure. Otherwise, it is same only. Huh? So, 1, 2, 3. Okay. So this is the outline. Okay, this is the outline. Okay. Now here, this is the axis.
Oh.
So what is the angle here? 109.5. All right. This is the one. And this is shape is. Shape is. Shape is.
কালকে সুদীপাদি এখানে নালে।
Right. And bond angle.
হ্যাঁ, কালকে এসেছে। কালকে আমি অঞ্জলি দেব একটু।
Is 109.5. We'll go for CH4, okay? So it is this. মানে কথাটা স্টাইলটা এইরকম, তো জঘন্য কথা হয়। Okay. Okay. This is this is CH4. Okay. So now, see, I'm doing only the axis here. Huh? What is this bond angle here? 109.52. Okay. So what is the shape? Shape is tetrahedral. And angle? Hundred and 9 point. Nitrogen. Nitrogen is 7. So 1s2, 2s2, 2px1, 2py1, 2pz1. All right. So this is ground state. And this is GS. This. And this is nitrogen hybridized state. See here, how many electrons are there? 2 plus 1, 3 plus 1, 4 plus 5. So it is 1, 2, 3, 4, 5. Okay. So what will be the hybridization here? It will be nitrogen. See, here will be pair. 1, 1, 1, and this is done. Okay. Now I'll go for now NH3. This is where come in the exam. Please remember. In NH3, what will happen? It is N here and C. This is called the lone pair. These are the bond pairs and this is the lone pair. Bond angle, of course, will not be 109. It is 107 because of the lone pair bond pair repulsion. Here it is 107.4 degree. All right. Due to lone pair bond pair repulsion. Now we'll go for oxygen. Hey, here you write nitrogen. The thing that you have written, written nitrogen. Okay. Now we'll go for oxygen. Now we will go oxygen. Okay. So now I'll remove all. So this is oxygen. Oxygen is 8. So 1s2, 2s2, 2p, 2py, 2pz. This is for oxygen. It will be this. Okay, please see now. Don't go on writing without understanding. We have mixed all. How many electrons are there? 2 plus 2, 4, 4 plus 1, 5, 5 plus 6. So 1. Okay. So it will be 1, 2, 3, 4, 5, 6. All right. So how it will look like? Look. This is oxygen. My drawing, I think I have to change my hand. Oxygen. Okay. So this, and this, and this. Okay. So I put one here, one here, one lone pair, the other lone. This is what. Now after finishing this one, then we'll go for example. Water. So please excuse me for my bad drawing. Okay. See here. So this is this, this is this, this is this, this is. So in this case, this is the hydrogen and this is the hydrogen. This is water. Okay. So this is also tetrahedral minded. Though VSCPR has, because VSCPR did not have any idea about this exact bond angle. So bond angle we know is what? 104.5 degree. Why? Because of lone pair repulsion. I'll take 10 more minutes. Okay. Now we'll go for Sp3D hybridization. Okay, so here we are going to take s orbital, px, so px, py, pz, and here I am going to take here dz square orbital, dz square. Out of the 5 d orbitals, dxy, dyz, dzx, and dx square minus y square and dz square, I am going to take dz square. How it will look like? It will look like this. This. See here, this is trigonal planar. Then this will be this and this will be. Okay, so it is, what is the shape here? See here. Here angle is 120 degree. And here the angle is 90 degree. You know very well what the shape. Shape is trigonal by pyramidal. Example, PCl5. So here I'm not going to draw all orbital, this electron and all this thing. So it is P, this. Okay, so this is this, then this, and this. Okay. So here you have one electron, here one electron, here one electron, here one electron. Okay. For this one, it will be here. For this one, the smaller lobe will be here. Okay. Now, chlorine is going to bind through p orbital. Cl. This. 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 So this. This is the what is the hybridization here? Here it is Sp3D. We have two types of angle. Bond angle, two types. Okay, what is this? We call it axial, 120 degree. And which is, sorry, phone. Equatorial, this. Axial is 90 degree.
Yes, sir.
Yes, sir.
Okay, now we'll do the last one. It is Sp3 D2. So it will be S, then Px. Okay, forget. S, Px, Py, Pz, then dx square minus y square and dz square. So how many orbitals is that? 1, 2, 3, 4, 5, 6. Okay, it will look like this. This, 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 this. Okay, so it will be this. Then one perpendicular to this, another perpendicular to this. So you'll have one electron here, one. What is the shape? Octahedral. Shape is octahedral. Angle is 90 degree. Example, SF6. So I write like this. S. This. 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 Then one. Other at the bottom. See, one. And angle is 9. So F now. So F is going to bind to p orbital. Yes. This is SF6. Okay, with this I finish the hybridization. After that, we are going to start a very important chapter, and the last chapter of chemical bonding is molecular orbital. Okay. Okay then. Bye.